We'll now take a look at a different loop, which we call the for next loop. The for next loop actually works just like for loops in other languages, such as C, C++, and Java. So let me give you the format for it. That way you can see how it's done in Visual Basic. It looks just a little different. So we have this setup for our for next loop. So we have the word for, and then we have k. K is just a specific variable. I'll talk a little bit more about it in just a minute. But then we have the words as integer equals 1 to 5. Now this is just an example here, but we would have the keyword for, and then as integer. So think of it as saying we're declaring a variable k as an integer, and then we assign it to 1, and then the 2 part means that we go up to 5. And then we have a set of statements, and then we conclude by having next and then k. So let me explain how this works. So k in this case is a variable. Think of it like a loop control variable for our for loop, and this is going to track the number of iterations. So we see here that k is initially 1, and after each iteration of the loop, k is going to be incremented by 1. That's what this next k means. Next k means we're going to get the next value of k. So that's the same thing as just incrementing it by 1. So what then happens is the next time we run this loop, k is going to be 2, and we keep repeating these statements until k surpasses 5. So once it's 5, it's true. So then k will go to 6. So that's false. So that means we would be done. So we can tell from this particular example that our statements inside the loop will run 5 times. It'll be exactly 5 times, no more, no less. And then when we're done with that 5th iteration, we'll just exit the loop because we've done all the iterations that we need. Here is an example of a for next loop. And so we see that we have for x as double. So we don't have to use k for our loop control variable. We can use whatever we want. So x is a double. That's initially 1.0. And we're going to continue this as long as it goes up to and including 2.0. And then notice that we have this step 0.1 here. You probably haven't seen this before, but we'll talk about this in just a little bit. Inside the body of our loop, we have a set of statements. Here, I'm just commenting it out just to say we have statements. We don't really care what it does. And then we have next x. So let me ask you this question. How many iterations do you think this loop has? Pause the video and just think about it for a bit. And when you think you have an answer, go ahead and resume. In order to answer this question, we need to understand how this step part works. So what we're doing here is it actually indicates how much x is incremented. So what this is saying is after each iteration, we're going to increment x by 0.1. This is similar to our update statement in a normal for loop. So if you remember, we'd have like for like int I equals 0, I less than something, and then I plus plus. Think of the step here as being that last part of the update portion of a for loop. So we're dictating how much we're incrementing here. So in this particular case, we find that we start at 1.0, and then 1.1, and then 1.2, and then 1.3, all the way up to and including 2.0. That's the key thing. 2.0 is valid. It's just once it goes past that, it's no longer good. So what we find here is we actually have 11 iterations. You may think it's 10, but we start at 1.0, and then we go up to and including 2.0. Now, if the 2.0 were actually 1.9, then we would have 10 iterations. But because 2.0 is the last value of our counter in this case, we do have 11 iterations. Here is another example of a for next loop, where here we have k, and it's an integer. It's initially 10, and we're going to go from 10 to 0, and then we see that our step is set up to be -1. Then we have a set of statements, and we just keep repeating this. So I'm going to ask you again, how many iterations do you think this loop has? Pause the video and resume when you think you have an answer. In this case, what we're doing is we're decreasing the value of x by 1 after each iteration. So we're allowed to decrease values as well, just like in other for loops from other programming languages. So we start at 10, then we go to 9, 8, 7, 6, 5, 4, 3, 2, 1, and including 0. 0 is valid. That means that we actually have 11 iterations. Here is another example, and this is a little different from what we've seen before. So we still have 4k as an integer where it's initially 1 and we go up to and including 10. That's fine. We have a set of statements. We just put a comment in it because we don't really care what those statements are. But the big thing I want you to take a look at is the if statement that we have inside of here. So this part right here. So we say if k mod 2 is 0, so we should know what that does at this point. So that's saying if we divide k by 2 and the remainder is 0, we're going to do whatever's inside the loop. So we have this continue for. What is that? Well, if you're familiar with other programming languages, this is actually the same thing as a continue statement in other languages. So continue for means that we're going to immediately end the current iteration of the for next loop, and we'll resume to the next one. So think of it as just skipping whatever's left over and this code, and then we just go on to the next iteration of our loop. So what we find here in this particular example, that the statement 1 section, that's going to execute for every iteration of the loop. Doesn't matter what k is, as long as the condition is true, we would execute all those statements. Now the statements in the section below it, the statement 2 section, that's going to execute whenever k is an odd number, because if k is an even number, we're going to execute this continue for statement here, which means end the current for loop, or at least the iteration of it, and then move on to the next iteration. Now this is something that's not unique to just for loops. We can use this continue statement for do loops and while loops as well. So we can say continue do, or we can say continue while. Now, what do we mean by continue do? That means the post-test loop, where we'd have do and then the body and then our while afterwards. So we can do continue do, continue for, or continue while for any of our repetition structures. We have one more example here to show, and this introduces another thing for repetition statements that you would find useful. So let's look at what this example does. So we have 4k as integer 1 to 10, same as before, nothing out of the ordinary. And then we have our set of statements that's commented. And then we see we have if k equals 5, then exit for and if. So we have this if statement right here. So here we have exit for. So what exactly is going on here? Well, exit for immediately ends the for next loop. Doesn't matter how many iterations we have left to go. We just completely get out of the loop. So this is actually like a break statement in other programming languages. So in this particular example, we would see that whenever k is 1, 2, 3, and 4, we're going to execute the entire thing. We'll execute all the statements in the statement 1 section. We'll execute all the statements in the statement 2 section. That's fine. But when k becomes 5, we're going to end the loop right away. We're not going to worry about when k is 6, 7, 8, 9, or 10. Nothing there we can do about it. We just skip all of that whenever k is 5. And we can use the exit statement for do and while loops as well. We can use exit do and exit while to break out of those repetition statements.